This is another fun, happy edition of Helium Hacks Happy Hour, where I get to figure out how to do all of the things that Travis does so seamlessly. So you're at the peak of it right now. We'll go ahead and let people sort of funnel in here. If in traditional Helium Hacks Happy Hour tradition, if anyone's new to the call, go ahead and just introduce yourself real quick. Open up your video, wave hello.
I guess Oscar and I are new, but we probably will have an introduction afterwards.
That's true. Yeah, we'll give you the very special introduction. All right. Well, I'm Joey. Longtime community member. I'm working as a technical program manager at DY and just filling in for Travis today. We have Microsoft with us to show off the brand new integration that is in the Helium Console. Yannik and Oscar, I guess I'll go ahead and let you guys introduce yourselves, and then we can probably jump right into some cool presentation. I know you got something ready for us.
That's good. Yannik, would you like to go first?
Yeah, sure. My name is Yannik Kopp. I'm a cloud solution architect for Microsoft, which basically means that I'm supporting our customers in implementing their cloud workloads in the Azure cloud. And I have a very special focus on IoT and a very special interest in LoRaWAN, which also basically brought me to Helium.
Great, excellent. And my name is Oscar Naim. I am a principal program manager in the Azure IoT engineering organization. I have been partnering with Yannik for a while because one of my main focus is LPWA and connectivity in general. And my role is to help customers and partners take advantage of our Azure IoT platform and listen to their feedback so that we can keep improving our product going forward. So back to you, Yannik.
Awesome.
Cool. Should we start right off, or is there anyone in the community who would like to say hello?
We did just add a couple more people while you're introducing. If you're new to this call, please do say hello. We'll give you just a couple seconds to jump in there. Don't be shy.
In the meantime, I will prepare my screen sharing. So to have everything ready.
Don't hesitate to just roll right into it. A lot of times folks aren't on in a good setting to say hello.
So you should already see my Azure portal, but we also got a little presentation ready. Okay, you should be able to see my my title slide. Can someone quickly confirm to me?
Looks great.
Sweet. Okay, so we had our introduction. Again, I'm here today with my colleague Oscar, and we will guide you basically through this presentation. We got some slides, we got some hands-on stuff, and yeah, I mean, if you have any questions during the presentation or the call, maybe drop them into the chat window or keep them until the end. We are more than happy to answer them at the end of this presentation. Okay, so our topic today is Azure IoT, LoRaWAN, and obviously Helium. And we want to basically jump onto this amazing integration that Helium has done. We want to show you some an architecture that we have built on top of this integration. We want to show you some devices and some pretty cool stuff that we have done. And we also want to give you some insights into Azure. And I would like to start with some, let's call it facts and figures, just as a brief overview of the, let's say, global network that Microsoft has built with their data centers. It's kind of like Helium with the gateways, but Microsoft is operating data centers, like more than 200 worldwide in more than 60, and they are combined in more than 60 regions. which is pretty nice because I can actually decide where in the world I want to host my services. So if I have like special requirements regarding latency or data protection, I can basically host the data in my own country or a special region. But like, I don't want to kind of show off numbers here. The main message I want to share is that basically, if you trust us with your use case, we will make sure it scales, that the services are running reliable, and yeah, and that your data stays secure. It's also mentioned on here that this is all powered by more than 4 million servers. And service is actually a great topic because it leads to my next slide. And this is kind of a bit of a history lesson here, because when we think about cloud, basically everything started with like virtual machines, virtual storage in the cloud as infrastructure as a service. And this is something that which also a lot of people, it's the first thing they think about when someone mentions cloud to them, basically yet another server that is just hosted somewhere in a data center. But over the past years, Microsoft has invested a ton of money to actually build some platform as a service components and software as a service components on top of this existing infrastructure. And the goal of this is to make it as easy as possible for our developers, our customers, to build their applications on top of these services. So they are kind of standardized. You can configure them. And yeah, you basically avoid writing a ton of code because this already has been done and by us, and you can really focus on delivering the best business value to your customers. And I got this super nice overview of all the services that are available in Azure. And yeah, you can see that there's quite a lot of them. We could probably fill days, if not weeks, when we want to highlight all of these services that are available. And today we're going to really focus on the analytics and IoT part in the down right here. So we want to show you how you can leverage these services, these platform as a services and software as a service components in Azure to very quickly implement your own IoT data, compute, storage, and visualization pipeline. So it's not that you need to write like a ton of glue code. All of these services are perfectly integrated with each other. And it's actually great fun to build IoT use cases and applications on top of this. So when looking at these components, basically the heart of everything is the Azure IoT Hub. It's kind of the endpoint for all the IoT devices. And for example, the Helium Console is just one potential data delivery system that is sending data to our Azure IoT Hub. You can connect a ton of other IoT devices, sometimes directly, sometimes a gateway is necessary. But we are really not restricted to one single data delivery platform. And this makes it very versatile when it comes to like building your use case, because you can combine sensor data from many different also connectivity technologies and sensor vendors. And then like after the data has been ingested via the Azure IoT Hub, we got all these like services around that can actually consume, compute, or store the data. And once the data has been ingested into Azure, we got these core Azure services, but around this, we also got like the Office suite from Microsoft and like the Dynamics suite, which then can leverage this data that is stored in the Azure cloud. And like business people actually love to use these services because it's super easy for them to consume the data and generate their own insights. So it's kind of this self-service approach that Microsoft is driving here, that allows people to use the tools to generate their own insights. And we will also highlight this during the presentation. So what we have done over the past few months, I would say, right, Oscar? We built this end-to-end architecture with a device, with a special tracker that Oscar will highlight in a few minutes, and ingested this data via Helium into the Helium Console, and then used the Azure IoT Hub integration to seamlessly forward the data to our Azure IoT Hub. And then we use this Azure function, like this serverless function, to decode the data. And you might ask yourself, okay, why didn't you use the nice decoder that the Helium Console offers? And the reason for this was that we had to do external API calls to a special cloud provided by Semtech to do the position computing. We had to call this external APIs, and that's not yet possible, or maybe it won't ever be possible from the Helium decoder functions that are available. And then afterwards, once we got basically the real sensor data and the tracker location, we used Azure Stream Analytics to distribute the data into different sources and to do some analytics on top. But we will all highlight this later in this presentation. So let's start basically at the beginning, at the start of the pipeline where the data ingestion actually happened. And Oscar, you got the device and the gateway with you.
Yeah, let me share my screen here and share. Okay, so here. Oops, I guess why did it go over there? Let me move over here. Okay, great. So this is the LoRa Edge tracker by Semtech, and it's the one that you are seeing on the screen here, the LR1110. And one thing that's very interesting about this tracker is that it doesn't have a GPS. It scans for Wi-Fi and other geolocation related signals in order to find clues in terms of what is the location where the tracker is. And it pushes all this information to the cloud, because all the computation of the location actually happens in the LoRa cloud by Semtech. And the idea with that is to make more cost effective that computation, and to save money, not only in terms of hardware of the device per se, because it doesn't have the GPS itself, but also in terms of energy saving, because of course, GPS consumes a lot of battery. So yes, and that's the reason why, as Yannik was mentioning, we needed to make those API calls in order to get the corresponding lat long coordinates. We are also using the Dragino gateway, and the reason we are using that one is because it's very convenient. I just got a few of these a couple of weeks ago, and all you need to do is install the Helium server on it. And it is a very straightforward process to do that. And once you do that, you just plug it into your router at home, and voila, that's all you need to do. You have the tracker. You register the tracker with Helium, and then it just gets connected to the network via the Dragino gateway. So is there anything else that you want me to show you now, Yannik?
No, just maybe quickly to mention, luckily it's not a proper Helium miner. So
yes,
we are not benefiting from now nice HNT that is generating, but to provide connectivity, this was perfect.
Yes, exactly.
Yeah, thanks. I was going to jump in and clarify just in case.
Yes.
So this would be considered a data-only hotspot, as the language
data-only
hotspot have been using. Yeah,
correct.
You just briefly,
and I don't remember, Yannik, if you let me know if you want me to show the console and the other aspects of the deployment.
Yeah, sure. Please.
Okay.
I think that's.
Yeah, because this is a very good tie to the whole story, so that people can see that there is a real implementation here. The integration with the Helium console was very easy. Here you can see the IoT Hub integration. We already have one defined, And you just need to provide a few configuration parameters, and that's all there is to it. Then you define your device. Here we have our LoRa Edge tracker, and we already have the integration defined, and just need to connect the tracker with that integration, and that's all you need. And you see that for the past several days we have had several messages going through. Here we have the actual IoT Hub instance on the Azure portal, showing the messages going through. And we have a Power BI dashboard that we created with an embedded Azure Maps. And this is an example of how easy it is to visualize lat-long coordinates with Power BI, because all I did was create a tile based on Azure Maps, and then import all the lat-long values, and that was it. Nothing else. So, yep, very simple. Back to you, Yannik.
Awesome. Thanks. Now that Oscar has basically showed us all the management porn with the nice visualizations, I want to give you some insights how we have implemented this based on the components available in Azure. And the first component I would like to highlight is, as Oscar was already mentioning, the Azure IoT Hub, basically our main ingestion point for IoT data. And it allows us to basically connect any devices that are out in the field communicating via MQTT, like very well-known IoT protocol. And we also have some fallbacks into HTTPS or AMQPS. And basically, if a device doesn't directly speak MQTT, we can always use kind of a protocol gateway, as we call it, to translate the protocol into MQTT. There are also like blueprints or open source code available how to do this.
Yeah, and Yannik, you're not showing your screen, by the way.
Oh, whoa, good that you remind me. Thanks a lot. Sorry for this.
We like to see the Azure Percept behind you, but
yeah, this is not the topic of today, right? Maybe once we have the Azure Percept connected with Helium, then we will speak about this. Yeah, I was actually showing this slide, so you didn't miss that much yet. So, and really the nice thing about the Azure IoT Hub is also that it scales with the workload. So I can start really small with a few devices, and I also pay basically this little price for it, but I can scale up to millions of devices and scale also the IoT Hub up. And we have definitely customers in the field leveraging this with several millions of devices in the field communicating via the Azure IoT Hub. And next to the IoT Hub, we're also providing a device provisioning service, which is not like super relevant for Helium, because this is already done by the Helium Console. But if you have directly connected devices to the Azure IoT Hub, and you basically just want to deploy them into the field with one single connection string to one central or global service, you basically can leverage this Azure IoT Hub device provisioning service, which then basically provisions the device and assigns it to the right IoT Hub that you would like to use in this case. Good. So let me give you a quick overview how this component actually feels in the Azure portal if we're going to use it. And I want to show you some quite cool features as well. If my presentation ends, good. Okay. So Oscar already has briefly shown the overview here, and I can basically just very briefly or quickly see, okay, what's going on this IoT Hub. And like one of the major components is kind of this device management. So I can see all the devices that are registered in here. And this is another nice fact about the Helium integration, that all the devices are like synchronized with the Azure IoT Hub. So if I'm creating a new device in the Helium console, it will automatically appear basically in my device registry of the Azure IoT Hub. And then once a device is created, it will also basically automatically get a so-called device twin, which is basically a JSON document which allows me to keep some static information about the device. So I could actually leverage this to keep some metadata about my device and have this as a single source of truth among my applications, and use this kind of as a device database, storing the data about the device. Just speaking about, for example, a vendor or a manufacturer of a device. And I think I briefly mentioned before that the IoT Hub is also bidirectional, allows bidirectional communication. And this is also implemented by the integration. So I can choose a device in here and send a message back to the device via my IoT Hub integration. So I can open this up. I can create a message body. I hope it works, so that it's translated automatically into hex. Let's just quickly check. So if I just send this out to the device, we hopefully see it in the console as well. So basically now a downlink is scheduled on the Helium console. And yeah, I mean, I have done it now via the portal, which is kind of just for the demo. But there's obviously a fully fledged service API behind the IoT Hub, so I can easily use this feature programmatically in my services. So let me see if a downlink has been scheduled, or maybe let me check in here, real-time packets. Yeah, I think we have some trouble joining the device at the moment, but I have seen it working. Promise. Okay, so this is basically the data ingestion part. And if you want to start basically using the data in Azure, which was generated by your devices, you got different options. You have kind of these built-in endpoints where you can fetch all the data that is landing from the devices. But I also have this nice option to do message routing. And the message routing allows you to basically check based on tags in the message, and basically do a routing on top of this. So I can define custom endpoints, define a route on top, and the Azure IoT Hub will basically dynamically analyze the tags. And if a tag matches the corresponding route, the message will be redirected to this endpoint. And this also includes a message enrichment. So if I want to use the device twin that I showed before, I can leverage this in this enrich message tag. So I can already actually join this data created or added in the device twin via this enrich message tag, message functionality. Good. So let's see what's next in our pipeline. So once we have ingested the data into the IoT Hub and it's ready for our services to be consumed, we are now looking at the serverless Azure functions. And that's actually a super nice platform as a service component, which allows me to run code without taking care of any runtime environment or even operation system. I really just have to deploy my code and define, okay, what kind of language I've written in my code, and then Azure will take care of everything else, of the whole the whole rest. And again, it's fully scalable, so I can start small and scale up to a billion of devices. And it's function-based programming, so typically an Azure function should really suit one single purpose. And yeah, as I mentioned before, you don't have to do any infrastructure management. This is all taken care of for you. And we have some really nice pricing models available. So basically the standard one is that you pay per run. And I think the first 100,000 executions are for free. So you can really test a lot until you actually start paying for this service. And again, I wanted to show you quickly how this feels in the portal and actually in a development environment. So I have my Visual Studio Code running. And this is basically the function which does this decoding of the data we get from our LoRa edge tracker. So I'm not sure how familiar you are with Python, but we are doing some decoding in here. We are basically calling this API and then receiving the latitude and longitude based on the data that was sent by the tracker. And this is all happening in here. And it's actually super nice to develop these Azure functions locally, because you got like with Visual Studio Code, you got a free development environment, and you get the Azure function runtime environment as well, so you can like directly test your function locally. So I can just run it here. It will start up. It will show you. You are even able to debug the whole function. And it's also configured to directly use the cloud output. So at the moment, my Azure function that is running locally will connect to my IoT Hub running in the cloud, and this will be trying to fetch the data, the arrived messages from there. So let's see if we. I don't think we have any messages waiting because the device had trouble.
They have been processed, and also because I'm not moving. And you really need to move to get the tracker going. So and you know, doing this kind of thing doesn't help very much. So
maybe you need to go for a quick run so that you can have some. So you have about like 15 minutes until your next part, so we can generate some tests.
And Yannik, we should probably also mention that this code will be open source in GitHub at some point in the near future.
Absolutely. Together, like the code will be open source and there will be like also the whole infrastructure will also be ready open source as infrastructure as code, so that it's super easy for you to deploy this into your Azure subscription and have basically a nice foundation to start with. So now basically I have developed my function here locally, and now I decide, okay, I'm ready to deploy this to Azure. And the only thing I need to do is basically choose the right function in here, or basically my Azure subscription, and then just click the like deploy to function app, and then my code will be basically seamlessly deployed to Azure into this kind of function environment. And now if we switch to the Azure cloud again, one second. I can show you how this looks like. Here we go. So this is my function app that is running in the cloud. Yeah, as mentioned, like we didn't receive any events lately, unluckily. But I have this fully fledged function environment. I can like monitor my function. I can see basically the number of executions. Yeah, basically we had some success. We also had some errors because I was testing some stuff, but it's basically all visible within this function runtime environment. And as I said, I basically developed this Python function locally, just deployed it to the cloud, and it was running seamlessly, and it keeps running until I basically say, okay, please stop now. Good, and like this Azure function takes care of the decoding of our LoRa message. And now let's move further in the pipeline. And that means we want to do some analytics on top. And for this, we got this Azure Stream Analytics component. And this basically does allow us to do some real-time analytics on top of the arriving JSON documents, because basically all the sensor data that we are receiving is handled in JSON within Azure. So we got different inputs. I mean, at the moment, all our data is arriving at the Azure IoT Hub because it's kind of dynamic sensor data. But I could also consume static data from just a storage account. And I can also use reference data stored in a SQL database. or again, like a blob storage, like an Azure storage account, to enhance or enrich the data that was sent by the sensors. And then once I'm done with my analytics part, I can seamlessly integrate this data into, for example, a visualization tool like Power BI, or a database, or even a data warehouse. Like, there are many different integrations available to basically seamlessly store or visualize my data. And that makes like Stream Analytics a super powerful tool to actually do this real-time analytics based on this dynamic data. And again, let me jump into the portal to show you how this looks and feels like. Unluckily in here, it's not that sophisticated, but I got some other jobs running from other projects that I have been doing. So this one is quite straightforward, because I just basically take everything that is arriving into Stream Analytics and just will write it into a blob storage at the moment. So there's not much going on here, but I can show you some other queries which are a bit more sophisticated. For example, here we got a job running, and it's a LoRa-based project. It's monitoring environmental data. And what's happening here is that I'm using some reference data that is stored in a SQL database. I do a join on a certain tag in the sensor data. And then basically with this join, I'm able to reference on the data that is stored in the reference database, and I can enrich the data that is arriving in my Stream Analytics. And it's if you're familiar with SQL, it's really close to SQL. So if you have some skills there already, it's quite easy to apply them into Azure Stream Analytics. And the other one I wanted to show you is even a bit more sophisticated, because it's kind of a rule engine which checks on thresholds. So this is kind of a smart building use case, and we are monitoring like humidity and temperature. And again, I'm doing this join of the reference data from the reference database, and then I'm actually checking, okay, is there a certain threshold reach? And basically every message is analyzed with this threshold. And if a certain threshold is reached, I will divide this data into another like data sync or a different output. And with this, basically, I can very easily implement kind of alarming system or pipeline. And like, this is basically, we are just scratching the top of the functionality of Stream Analytics, because I can do like also quite nice stuff with aggregating data over certain time frames. So I can basically aggregate data over 5 or 10 minutes, or I think it's up to 7 days, and do aggregations on top of this, and then like do analytics with the aggregations that have been built. So there is really like it's a really powerful tool to do this real-time analytics. Okay, so and once we are done with this, the next part in our pipeline is basically to generate the business value. And basically for this, I would like to show, or would like to present to you Power BI, which is kind of the go-to visualization tool when it comes to actually making use or show data. We have Power BI. Oscar was briefly showing it before with the map that was implemented there, just showing the latitude and longitude. But I mean, you are like, Power BI is a really fully fledged business intelligence suite, which allows you to import different data sources and then build visualizations on top of this. And again, I mean, in the use case or the architecture that have been presented here, we were basically just visualizing latitude and longitude on a map, but I also wanted to show you some other cases that I have implemented in the past, which I'm actually allowed to show you. Because they're kind of hackathon projects. So one is again, visualizing this environmental data, and again, showing a nice map. I got some sensor data visualized, and it's just super easy to create these visualizations based on top of the data that was streamed into certain data sets or a database. And yeah, this was the one case I wanted to show you, and the other one was a smart building case. So you can see here a floor plan implemented, and we got a kind of a heat map based on the temperature. And yeah, then you can basically step into the rooms and check the temperature over time and humidity and so on. And yeah, I'm really really no business intelligence expert, and still I managed to build these quite nice looking reports here. So again, I got this desktop application, but Power BI is also available on mobile, so I can basically also check these reports on mobile. And it's also available in the browser, so it's really a nice way to consume the data then.
And in fact, the one I was showing was actually the report on the browser. And it's also worth mentioning that on the phone, the UI is a responsive UI, so it will adapt to the device. So you don't need to do anything. All the reports will be basically adapted for that particular screen size.
Yeah, absolutely. Thank you, Oscar. And I mean, now I'm basically, this is mainly focused on IoT data, but next to the IoT data, I could also put in maybe some, for example, weather data. So I can really tap into a lot of different data sources, all consolidated in Power BI. All right. Okay, and that's basically like the the pipeline we wanted to show you, implemented with the different Azure services. And yeah, I mean, we got this code we had to write for the tracker decoding, but everything else is basically running just by configuring the service within Azure. So it was super straightforward for us to create this architecture. And as I mentioned before, we will provide this architecture to you in our GitHub repository. We will let you know, probably also via, hopefully, Helium allows us to publish this via Discord. So to let you know once this is ready. Okay, so now that we had a look at this architecture, I want to show you what's next on our roadmap. And there's actually one components we can't miss, or one big, quite central component. It's also called Azure IoT Central, which is quite a highlight in our IoT landscape. Because if you remember the slide I've showed before, right? We got all these nice services which allow you to build your own basically IoT architecture. But yeah, I mean, to be honest, even though they integrate quite nicely with each other, you still need to have the skills basically to put them together. And I think our product group has realized this and basically came up with the conclusion that we need to make it easier for our customers to build their end-to-end use cases. And they came up with a product called IoT Central. And it's basically built on top of all of the services I've shown you before, and abstracts them with a nice dashboard, and allows you to basically build your applications based on this so-called application as a service platform. And yeah, we allow you to basically build your use cases on top of these of the services that are hidden below this IoT application platform. And it's ready for your end-to-end use cases. So you can bring your sensors, you can connect them, you can visualize the data, and everything is nicely abstracted in this dashboard. And again, it's enterprise grade, it's fully scalable, and basically ready for prime time. Did I miss anything here, Oscar? Did you have any additions? Because
no, well, no, well, I guess we should probably also say that IoT Central is an application as a platform kind of service, and this is a concept that's going to keep evolving, because on one hand you have all the different PaaS services, and then on the other hand you have everything managed from an application point of view in IoT Central, and these two are separate concepts today. You can expect them to kind of like become seamless as time goes by, and so it's going to become easier and easier for the user to move from one to the other. So
yeah, that's perfectly summarized actually. And that also brings us basically to the next slide here, and you already can see we're also offering these kind of blueprints within Azure IoT Central, kind of existing use cases that have been done that can be reused as a solution, as a foundation for your own IoT use case that you want to implement. And again, basically it takes care of all your IoT data and then nicely integrates with all the let's say data consuming applications that Microsoft also provides on the business side, like Power BI I've shown before. We also have this no-code development environment called Power Apps, and basically all the other Azure services which help you to compute and present the data. All right, and this brings me to your final part, because like Azure IoT Central is also a perfect foundation for Azure Digital Twins. And you give us your insights there, right, Oscar?
yes. Let me share my screen. There we go. So hopefully you should be able to see my screen. Great. Yes. So digital twins. So the first thing that I wanted to say is that the concept of digital twins is not a new concept. And I believe the first one to brought this in was NASA, and it was for the Apollo missions, because of course, you can imagine the complexity from an engineering point of view, putting a device in space. And we see that today with the rovers that are on Mars. I mean, that thing is amazing, even the helicopter. And imagine managing that from Earth, right? So there are so many things that can go wrong. And having the ability to model and simulate that device, it's critical. Today, mostly, we started with just doing connected assets. So you had an asset, say an elevator in a building, and you started to generate information and push that to the cloud. How many times the elevator goes up and down, in what floor it is, how much weight it is carrying, the temperature, etc. And that's useful information from the elevator itself, because then the elevator company can use it for predictive maintenance and all sorts of other things. So that's great. But let's say you want to start enabling other kinds of scenarios where you have several people on one floor and they are all calling the elevator to go to another floor. If you had more information about what's happening in the building, now all of a sudden you can start controlling the flow of people within the building and making it more efficient. But for that to happen, you need to be able to have a connected environment. And of course, when you look at the smart city, what you have is really a system of systems, and you need to be looking at connected ecosystems. So this is where digital twins comes into play, because you need to be able to model all these environments in a way that that makes it possible to represent the scale and complexity. We have identified several areas where we are investing from a digital twins point of view. scenarios in manufacturing, retail, real estate, cities and government, healthcare, agriculture, education, finance, energy. And you take, for example, manufacturing. We have multiple examples where you are monitoring a machine in a plant, right? And of course, the typical use case is you do that for predictive maintenance. But if you want to monitor the whole production line, then not only you need to be able to monitor these individual components, but the whole line. And in many cases, the output of one plant becomes the input of another plant. So if you have a quality issue in plant 1, that might affect plant 2. So you need to be able to take into account all these different interactions. So if we look at this nice representation, and let's say we have our LoRa Edge tracker in a pallet, and that pallet goes into a truck. Yes, we can certainly monitor where that pallet is at this moment in time, because we can track its location. But let's say that we want to enable a more complicated scenario, and we want to be able to look at the whole system, right? So let's say this is a supply chain scenario, and the tunnel that's right in front of that truck, it's closed, and it needs to basically take a detour. That can affect the supply chain. So perhaps now we have to schedule different deliveries from another truck to that other location, to the warehouse where that thing is going, so that it can get on time. And the only way to adapt dynamically is if you have information about the whole system. Now, building digital twins is not easy typically, because there are many issues that you have to face when you're doing this. So on one hand, these models could be very complex. Also, you're dealing with siloed data, all over the place. You also need multiple building blocks that you need to consider when you are building the solution. And what you build has to be scalable, because otherwise it's just a toy. And then you need to sync that digital twin with real world updates. So that's where our Azure Digital Twins product comes into play. And for this, I want to show you a very quick video, because it summarizes the vision of Azure Digital Twins. So let me play that again.
Imagine our world today. People, vehicles, businesses, buildings, hospitals, factories, entire cities, and the billions of devices that connect us to this world and to each other. This is the physical world. But what if we can replicate that physical world into its digital twin? A digital twin that is bound to the physical world in real time, that we can experience in mixed reality, that we can collaborate with, that we can run simulations on and find what is important to us, that we can apply AI to learn, predict, and act, to save time and money, to reduce carbon, to preserve natural resources, to improve safety, to bring us all closer. This is already happening today. Across the world, organizations are taking advantage of this new wave of innovation that trends to an interconnectedness that enables the metaverse. Everything modeled in the metaverse mirrors the status of its physical twin, including the interactions and relations between everything else. By applying the power of the cloud, we eliminate boundaries of what this can do. The potential is limitless. We can now track and analyze data from connected environments to identify patterns, trends, and anomalies. We can now simulate any possibility, evaluate outcomes, determine the impact of any change or condition. We can now harness AI to perceive the physical world to improve and automate tasks, to give superpowers to your frontline workers. We can now give everyone in your organization the power to build apps and workflows, to collaborate with each other in this virtual space, to share and receive expertise at the right time with the right context in front of you, to move through the physical world and get relevant information about its digital counterpart when and where you need, using mixed reality. The Microsoft Cloud brings these capabilities together with the limitless computing power of the cloud and intelligent devices at the edge, and creates this framework for building immersive and impactful digital twin, mixed reality, and metaverse solutions.
And by the way, a couple of things about the video. Any similarities with the upcoming Matrix movie, it's all a coincidence, by the way. But also, I wanted to say that what you see in the video is not made up. This is all based on real use cases and real deployments. So it's amazing because we are beginning to see the realization of that vision. And of course, it's going to keep evolving because things are going that way. That's for sure. So with Azure Digital Twins, you can today pretty much model any environment and bring it to life with real world data. You can query the digital twin graph, which is the instantiation of that model that you have built. You can query it and basically get answers to your business related questions. You can connect any data to it, from IoT to business systems. You can route data from the digital twin to any external point for integration with other services. You can manage access and identity with role-based access control. You can bulk import for massive deployments. We have a tool called Azure Digital Twins Explorer that I'll show you briefly in a sec for visualizing and interacting with the graph in 2D. And we have a 3D version that's upcoming soon as well. We have Azure Data Explorer integration for data history. And this product, it is enterprise ready. There are multiple partners and customers that we have today actually using this product in multiple ways. So let me now switch to, yes, okay. So here, let me actually move this here so that I can go through the tabs. This is the portal, the Azure portal again, and this is an instantiation of the digital twins. I won't go over this because I already talked about most of the details here, but basically this is how you first create your digital twins. And one reason why we are able to model anything is because we use this language called Digital Twins Definition Language, or DTDL, which is based on JSON-LD. And it's a very powerful language that allows you to model anything from people to places, processes, and things. Then you bring that to life by creating a digital representation of that graph, which is called a digital twin graph. And in that graph, you basically overlay all the data that's happening in the real world, and you have to keep it up to date and in sync. That way, you can actually query that graph and get the answers that you're looking for. And you can also, there are many extensibility features that allows you to add business logic, data processing, and integrate with other business systems. But now let me actually show you. This is the Digital Twins Explorer. If you go to GitHub and you search for Digital Twin Explorer, you'll find the project. And I basically, deployed the solution on my machine. It's very straightforward. And of course, this is a very simple graph, but I just wanted to use something simple to make the case. This is a building that has floors and rooms. And if I click in one of the elements of the graph, it'll show me the properties. We have two properties here, humidity and temperature. And then I can actually query that graph. And with SQL-like queries, I can find, for example, all the rooms where the temperature is above 75 degrees. or I can change it and look for the opposite, all the rooms where the temperature is below 75 degrees. So as you can see, it's very easy to interact with the graph, again, SQL-like kind of queries, and a very powerful kind of visualization. So with that, back to you, Yannik, so that we can close.
Absolutely, absolutely. And I think one highlight feature also of the digital twins is that information changes within the digital twin are automatically propagated through the different levels, right?
Yeah.
So that actually, if, for example, a temperature changes in one room, this temperature change will actually propagate it to the next level, which can then maybe be the floor. And with this event trigger, you can then start build your basically logic on top of this. All right, I guess we can close the presentation. This time I won't forget to share my slides again. 1 second. Good, here we go. Okay, I just need to quickly jump through here. Exactly, and just a quick, it's not really a call to action, just if you want to get your hands dirty and want to start with testing our services in the Azure cloud, it's basically free. You can sign up, use most of the services available, even offer a free tier so that you don't ever have to pay.
We're not seeing anything, Yannik, by the way.
Oh.
Yeah, perhaps you forgot to click share. Is that happened to me the first time?
Oh, yeah, you're right. Again. I really wanted to
work.
Now it works.
Okay.
Sorry. Now I messed up my whole nice call to action. Again, okay, this is just what I wanted to show.
Yeah, there you go.
Yeah, I mean, I don't think if you probably can't click the link, but there should be a link in here. Just quickly Google for the basically the Azure free account, and yeah, you can see that we got a lot of free services. You get this $200 Azure free credit, and we will also publish basically the architecture I've shown before onto GitHub, so that you can very easily deploy it into your subscription. And yeah, just like get started in the Azure cloud and get your hands dirty. Yeah, I guess that's it from our side. So let me quickly switch to the last slide. So yeah, feel free to shoot any questions at us. You find our contact info in here. Feel free to connect. If you want to discuss any nice IoT cases or IoT cases in general, feel free to reach out to us. We are more than happy to support you here.
Yes, indeed. We're very interested in LoRaWAN-related cases. Microsoft recently joined the LoRa Alliance, and as you can see with the integration we have done with Helium, this is really a very strategic area for us. So any interesting use cases that you have in this area, by all means, let us know. We'll be happy to help.
Yannik, Oscar, this was a fantastic presentation. If you have a couple minutes, we'll usually open things up to questions if anyone has any
Sure.
right now.
Sure.
I think everyone's in a little bit of a state of information overload. There were so many things in there, and you answered so many questions along the way.
I like the quote that the Matrix is nonfiction. I like that one.
Oh yeah, I mean.
If you ever get a chance to play with this HoloLens, maybe at the conference or something, it's amazing. It's really next level, and you have the feeling you're already in the future. So the possibilities there, it's limitless.
Those are certainly really cool. What's really exciting about all of this is we have, especially on this call, a lot of folks playing with sensors and sort of discovering all of the opportunities that are available there. And I think sort of the next frontier for a lot of folks is figuring out what to do with that data. And, the presentation that you've put together, I think, offers a whole range of solutions with that in mind. I think we're going to see a lot of people starting to hack on the Power BI platform just to sort of start getting these dashboards together as an outlet. of, oh, Travis just reminded me, we can give one of these away. So speak up if somebody has some cool IoT use cases that'll fit right in with this this newfound knowledge. But yeah, finding ways to get data straight out of Helium Console and into a database, and then representing that through Power BI. I think we're going to see some people playing there.
There is a question: does the free trial give you full use? And for the most part, yes. You know, it varies from service to service, but in many cases you have a free tier, and in the cases where you don't have a free tier, the $200 that you get when you sign up for Azure, first, that goes a long way, because all you need is to be careful and only select really the scale that you need, and for a few devices, few messages, you know, it's just pretty much everything is free, so that shouldn't be an issue.
Can I ask a question?
Yes, please.
Thanks for the presentation. I actually had to leave briefly, and because I was so intrigued by the non-GPS tracker that you had shown at the beginning. I have a potential client that's interested in asset tracking, and where I live in southern British Columbia, there's quite a few areas here where they don't have like cellular data coverage, right? But there's actually LoRaWAN coverage, at least from what I can tell when I go around with my mapper. So I'm wondering, could I use your platform to create, just to start with, a simple sort of white label asset tracking service for them? And the second question is, do I need to be like a developer, or can I do most of it sort of with no code and sort of pulling together the widgets and so on?
I think for the most part, so let's go, you know, one thing at a time. I think LoRaWAN might be, you know, a very good choice. At some point, though, you need to connect the gateway with the cloud. So typically, if you can find a location where you have the gateway and then use cellular to get to the cloud, and then all the sensors connecting to that gateway, and the gateway is in a good location so that it can see up to, you know, 10 miles or so, you know, we have many use cases in remote locations that do exactly that. And the LoRaWAN network, because it's on licensed spectrum, it's pretty much like a private network. So you don't need to do much to get that running. And then from building a solution point of view, most of the code that was required for this was for the translation of the payload from the tracker to lat long, and we did that, and we'll make it open source. So if you leverage that, it's just the application layer probably that you will need. And if you use something like IoT Central, then it will really be just configuration, if at all, that you will need to do.
Okay,
actually, this reminds me of a good point, because one thing I missed to mention is that at the moment we have, like with Helium, the IoT Hub integration, right? So we can seamlessly send data from the Helium Console to IoT Hub, but obviously our goal is also to seamlessly integrate IoT Central, and we will definitely working with the product team of Helium and our developers to basically integrate also IoT Central seamlessly with Helium, which makes it even easier for you to build your application on top of this.
Yeah,
great. And can it be white labeled, or would they like, so it would look
yes,
like my own solution? Yeah. Okay.
yes, it can.
Great. Thank you so much.
No worries. Thank you.
I have a question. I missed quite a bit of the presentation, so if it was covered, forgive me. But I have a client that wants daily reports from tracking, and currently we're using a satellite system, but I have access to the API. But the only reports that are available from that service is just an Excel spreadsheet. But the client wants a pretty report that has like maps and locations of all the different assets. And I've been trying to find a service that I could generate just like a PDF report that's emailed daily that has, I could break down assets by location because they have a fleeting area. It's a global barge transport company, so they want to know where all their barges are in the world.
Mhm.
And so I can't find anywhere where I can create these, these custom reports that show a map by location, and then also be able to break it down to where if there's a barge that's not in a fleeting area, but in the middle of the, say, the Gulf of Mexico, they don't get a map that's just blue water or brown water, whichever one we're down here in Mississippi. So something that's smart enough to either realize that it's a regional map that they need or something a little bit more detailed.
Yeah, I think this is exactly where Power BI actually has its sweet spot. I mean, you could even like start with just integrating the data from the Excel sheets into Power BI just to visualize basically the Excel sheet data. And then in a second point, you could think about like directly streaming in the data from the satellite service into Power BI. So this is definitely this use
like
case.
A get from the API. Or,
Mm-hmm.
okay.
So-
Absolutely.
And the other thing is, because of the integration with Azure Maps, so when I showed my Power BI report, it was actually an Azure Maps tile. And so basically, all the mapping parts will come from Azure Maps. And so that would be very handy for you for visualizing any geospatial kind of data.
Right.
Now, there is also Cosmos DB and the ability to represent geospatial data and store it like that. So, depending on the size and the scale of your project, then, might be worth considering that as well. But from a reporting tool point of view, certainly Power BI will be like a good choice to get started with the integration with Azure Maps. And by the way, that integration is in preview. So you need to, in Power BI desktop, you need first to enable private preview features so that you can see the Azure Maps style. So, and if you Google it, it's very straightforward, but, at Microsoft, for some reason, we like it to make it a bit more complicated. And you have to do the extra step to get there. But
is there like a pretty robust community of like a forum that people help each other out with? I mean, because some of the other ones that I use, you could go on there, but there might be 1 or 2 posts per day. So you post like a question for help, and it might be a week or 2 before somebody.
There's definitely like a worldwide community available.
Okay.
Because yeah, I mean, on one side you also have Stack Overflow, but we also have kind of a Stack Overflow like community in our own like forums.
Okay.
So you will definitely find help there.
yeah, but I think your use case is straightforward enough that you should be able to have everything you need for it.
And I mean, it's 2 positions a day that we're starting out testing with 1, and then they want to grow and then be able to expand beyond just like large assets to smaller assets as well. So
Cool.
Very cool.
Yeah.
all right, I'll start by Googling and get my account.
Sure. And I mean, if you need any further information, just feel free to reach out.
I wrote down your email addresses, so
Perfect.
There you go.
don't
And there is
block
Yannick's
me.
phone number there as well.
Good.
Cool. Well, I'll delay us for a little second just in case somebody else has another question. But otherwise, thank you both for jumping on and giving us such an in-depth overview of everything that you've been working on and are bringing to the Helium ecosystem. I'm really excited about that.
We're not done yet. Stay tuned.
Thank you very much, Joey,
Yeah.
and the Helium community for this opportunity. We really appreciate it. Thank you.
Great. Yeah, we look forward to seeing more.
Okay.
Cool.
Will do. Take care,
All right.
guys.
Thanks,
Happy New
everybody.
Year.
Take care. Bye-bye.
Bye.